Assalamualaikum. Okay, good morning. So it depends on when the time that you watch this video. So this is development of color sorting robotics arm using TCS3200. This is for the IEEE conference on system process control, ICSPS 2021. Okay, and this is my team member, my name and my students and my friends and my group member and supervisor for these projects that I have here. So this is the flow that for my presentation: the introduction, the study aims, objective, methodology, result discussion, and the conclusion for future work and reference. And finally, I will show you a demonstration of what we have done for our projects. Okay. So a light intensity of frequency converted meter is used to detect color. Basically, this is the sensor that we will use. TCS is able to use the frequency to measure or to calculate what types of color that is produced by the objects. And at the same time, robotic arms will be controlled by DC servo and microcontroller, and as well as an IoT platform will be used to monitor the detection process and how is the performance of the sensor. So this is the conclusions of what we have conducted. Basically, it's 95% efficiency at right condition. This one is based on a 5 centimeter length or 5 centimeter distance from the sensor to the object. Okay, and we also set the distance 1 centimeter, 5 centimeter, 10 centimeter, and 15 centimeter to see whether how is the performance lah in both fully light and dim conditions. Okay, so this is just a graphical representation of a robotic arm for those who are not familiar with the robotic arms. But we are using a very simple robotic arm just to see the process we would like. So basically, the study aim of this process is to design an architected robotic arm that can perform a simple repetitive task using a gripper with pressure pad to place a 0.1 kg object on a designated place. The system is assist with the TCS sensor. The sensor, the motor that will be used is MG90s with ASP8266 for the IoT part, whereby the information of the color is transferred to our IoT platform, and Atmega Arduino IDE as the main microcontroller. So basically, it is the principle of this project is to the research is basically to able for the sensor to detect and move the robotic arm at the same time to transfer the data to the cloud. Okay, and we are using a ThinkSpeak platform as part of the IoT applications. So the objective of this research is basically to compare the efficiency of the robotic arm in both indoor and outdoor at different length, as well as to analyze the RGB values under warm and neutral light, and to provide the robotic arm to students at lower cost possible. So this is the created based on the due to interest of robotic arm for students. So we also make it possible for students at any type of age to learn about robotic arms and to develop their own sensors. So we have our component, first chart design, and the design that we propose, and then the real product, and then the circuit construction for that particular part. This construction also involves the IoT part and the testing of the platform. So in terms of current, we are using MG90 servo motor, 180 degrees, TCS3200 color sensors, and lithium ion for powering our robotic arms, and Arduino IDE ESP826645 modules. And also the acrylic sheets that will be the base of the robotic arms. So basically, this is roughly the flowchart of our program. We set the position of the motor initially, and then read the frequency, and then it will able to detect with detect the box or the block that we will use, color blue, red, or green, and then it will publish the blue counter in the ThinkSpeaks and then rotate the position of the blue box position into the right position to put or pick the box and put it at the right position of where we want the box to be put. So currently we are only using three types of color, red, blue, and green, RGB. So initially, this one is what we designed. So we have the color block, the shoulder servo, the gripper servo, base servo, color sensor, and block placement. So basically, we are using a 4 DOF, each different joints. Okay, one for the gripper, one for the shoulder, one for the base. So I think this is supposed to be 3 different joints. Okay, and then servo rotation in so 1, 2, 3, 4, I think 4, so 4 different joints. Okay, so for rotation limitation is 0 to 180, and the torque is 2.2 kilogram, and the color sensor that we will use for our analysis is 1 centimeter for our testing, and then for analyze we further do for 5 centimeter, 10 centimeter, and 15 centimeter. So color sensor input voltage is between 2.3 to 5.5 volts only, and then the platform that we use is the acrylic sheets. So this is the final product that we have. We have our 3 different color blocks, and then we have this our robotic arms, and then this is the color sensor. So this is from the side. So this is from the side, and then this is from the top. Okay, so we have these different 3 types. So this is our Arduino. This is our power supply, and this is the 3 box, and then this is the acrylic sheets, and then this is the color sensor that we have here. So basically the idea is for circuit diagram is straightforward. Okay, we have this Arduino and then these 4 DOF motors with the power supply by the TCS sensors connected to it, and then we have additional of the Wi-Fi module to communicate with the IoT platforms. So whatever sensor that is detected by the TCS3200 will be whatever color that is detected by the TCS sensor will be transferred to the IoT platform. Okay, so basically the idea is for the TCS is just to convert the frequency into the correct currents that can be read by the Arduino, and therefore the color will be transferred into data that can be transferred into the Wi-Fi module to the ThinkSpeaks. Okay. So this is the final result and validation of the frequency outputs. So we have here. So this is the when the color is detected changing in different temperatures. So this is the data that we generated. So this is the red, blue, and green, and then there's a red, and then blue, green, and so on. So you can see that the color between the red, blue, and green doesn't overlap. So they have a distinct color pattern between it. Okay, but in some cases the color can be overlap with each other. Okay, because due to that, then the efficiency will be reduced. Okay. So this is the other warm light. So this is how we construct our testing. This one is at 1 centimeter. We just want to test whether the color can detect. So we put a paper with the matching colors and see whether our sensor able to detect it or not, and show the right color. So this one is supposed to be showing green. Okay, and then we also show the pattern at neutral, warm and neutral lights. So, and then this one is, and then after we turn on the light, okay, so the value will increase. So meaning the color will be showing a distinct different pattern here. So final result and validation of outdoor during the daylight. So we also conducted outside the house Okay, and then this thing is a sample of what is showing the red at 1 centimeter distance that we have. Okay, and so this is what we see in the graphical pattern. So you can see that in between the blue and green, there is a slightly overlapping between these two colors. So this one we want to try to avoid. Okay, but this one is the 5% not we get 95% of efficiency in daylight system. Okay, so this is when we put a box a distance away from the sensors at 5 centimeter, 10 centimeter, and 15 centimeter between, and then we use both bright, dim, and then we take the average. So we see that in average, the bright and dim overall can detect at 5 centimeter. Of course, at 1 centimeter, of course, it will be 100%. But at bright and dim, the percentage dropped to 95.99, or in average 95%, and then it will further drop to 75%. In dim, of course, the percentage dropping, and detecting the color sensor of green is very poor, 25%, and then 15 centimeter is further away, so it's 41% drop, and average is 43.43%. So using TCS3200, it is better to at maximum of 5 centimeter distance away. 1 centimeter is very good, but 5 centimeter is should be enough for the applications. So this is also what we have conducted using the monitoring using the TeamSpeak cloud. So basically, each color detection is counted and published to the TeamSpeak. The color is counted by the microcontroller. TeamSpeak only receive the value counted by controller and shown it. Okay, and then we take the values and we show the value of our what the blocks color that we have shown. So in discussion, the color sense objective have been sorted according to the RGB values, but based on the distance. Okay, no problem for the sensor to detect. And then to calculate the right color frequency for each of the blocks, K nearest neighbors algorithm is used. The other project did not the other project only did the sensor test indoor. So this is what we have conducted is outdoor, two different types of colors and different distance. And for those students can afford it at lower cost possible to learn the system, meaning you can learn the sensor, the robotic arms, and the IoT platforms. And it show a good accuracy of detecting the color, especially at 5 centimeter and below distance away from the session. So in future work, okay, since the sensor is able to detect the color at outdoor and indoor conditions, so it is good to analyze our surrounding lah, whether even though it is dark or light. Okay, and so even though the color change, the color temperature change, you can still able to detect, sort, and send the items remotely to the IoT platform. So based on this research, it can be concluded that the data counter accuracy depends on the amount of each. Basically, all the objective for this project is achieved, and it is very useful for university students, especially during the COVID time, to test this robotic arm system. Okay, very short. So this is a project is supported by the University Tenaga Nasional under the grant program we have. Thank you, UNITED, and thank you, ICSPS RTPE for conducting this program. So this is my referencing. And finally, I want to show you the demonstration. So this one is the detection of the blocks. So this is green, so it's supposed to be to this green block here. Okay, and then show red. Okay, and we show it to here. So overall, the objective achieved, and at the same time they able to transmit the value into the IoT platform. Okay, with that, I think thank you all for listening to my presentation. Bye bye.